Stanford University.
Welcome to Lecture 9, iPhone Application Development, CS193P. Today we're going to be talking about data in your iPhone application. I'll explain in a little bit what exactly that is meant to encompass. But first, let's do the usual slew of announcements. First of all, Presence 2 is due next Tuesday on the 5th at 11:59. Presence 2 is due on Tuesday. If you have any questions, you can ask them now or over email or whenever. Any questions? You probably haven't even looked at it yet. We just put the assignment up on the website last night, actually, so probably not surprising that there aren't questions. Along with the Presence 2, like the assignment handout, the PDF, there are some files that are going to go with it. We gave you some sort of starter files for parsing Twitter content. So rather than having to roll your own, we're kind of giving you a leg up, and you're just going to call into some methods to actually do the Twitter fetching. But we're actually going to be explaining today how all that stuff works under the hood. Another announcement, it looks like, knock on wood, the Friday sessions are going to be taped. A little last-minute flurry. So look for it on iTunes U. This Friday will be the first one available with Lauren Brichter. There's his URL. And it's in 200-205 as usual. So that should be pretty cool to have that up on iTunes U as well. Thank you, Troy and crew and the video folks for making it happen. The last announcement, oh yeah.
What's it on Friday? The lecture?
What's the content? Lauren is an independent app developer. He's written, among other things, a Twitter client for the iPhone, which is pretty well regarded. And he's a former Apple employee. So you can get his take on iPhone development and anything else you want to ask him about. Anything else? Pretty cool. So final projects. We mentioned that a few weeks ago, and you've probably been wishfully ignoring them up until this point. But we wanted to get you thinking about it again. First of all, groups of 1 to 2 people. I guess it's not really a group if you're just by yourself. But we found last time that groups of 2 tended to work out pretty well. We don't want to have these massive sort of teams where inevitably there's someone who does all the work and some guy who just managed to sneak through without doing anything. So by yourself or with a partner. You're going to be doing this during the final 3 weeks of the course, so there aren't going to be any assignments during this time period. The projects are going to be due on June 7th. That's a Sunday at midnight. The usual submission rigmarole. We are going to ask you to submit the code because we want to, yeah, that's just part of the deal. And then the presentations are going to be during our final exam time slot on the 8th, June 8th. From 12:15 to 3:15 p.m. So we're still working out the details of that, what exactly it's going to entail. Obviously, we'll probably have 40 some odd projects and 180 minutes of time. So we may try and do some sort of rapid fire presentation thing where you send us keynote slides and you do a little song and dance up here. And probably the most salient thing for right now is that we need to give you a thumbs up as to the project that you're going to undertake. We want to make sure that it's not, way too hard, and we want to make sure that it's not, Hello World or, Presence 4 resubmitted. So you don't need to tell us, it's not going to be a huge amount of detail, but there's going to be a PDF on the website this evening, sort of what we're looking for, the amount of detail. You're going to send us an email just saying who you are, what you're going to work on, who you're working with, and we'll send you an email back, most likely just saying, great, go for it. Do your thing. So please do that, and the deadline, for what it's worth, is the 11th. We'd like to have everyone sort of ready to go and not still sort of figuring out what they're going to be working on. And one question that we have gotten quite a bit is, do I own the final project, or does Stanford own it? And as with most sort of project type classes at Stanford, you are the owner of this project once the quarter completes. So. The area where it starts to get a little bit fuzzy is if you're using some substantial amount of Stanford resources, like you've got some big, rack of servers down in the basement of Gates that you've been using as an integral part of whatever your application is. I think that's when it begins to, there may begin to be a dispute of some sort. But for the most part, you guys, you make it, you own it. Any questions about the final projects? again, feel free to send us an email if you have any questions about anything regarding that. And yeah, start thinking about what you're going to work on and just shoot us an email with your proposal. Also, before we get into the meat of the lecture today, we had a couple of frequently asked questions. These aren't really questions, so I call them frequently encountered issues because they end with an exclamation point instead of a question mark. But one question they've been getting a lot is, hey, I've got this object, I'm calling this method on it, and it doesn't do anything. I'm calling, set text, or I'm calling, set background color, and it doesn't have any effect. The first thing that you're going to want to check here is whether the object is nil. Because remember, in Objective-C, messaging nil, sending a message, whether you're telling it to do something or you're asking for some value, messaging nil is allowed, and it'll just silently fail. And there's a lot of cases where this is really useful, and it helps you to avoid writing really repetitive code, which is like, if not nil, do this, if not nil, do that. And as I mentioned, if the method has a return value, like you're asking the object whether it's hidden or whether a Boolean or an integer or even a string, it'll return 0 or nil as the return value. So if you're calling set text and then you're asking for the text and the text is nil, probably means that the object is nil. So what you want to do in this case is either use the debugger or use the NSLog statement. You can just sprinkle this into your code wherever you like and try printing out the object. This will probably give you a hint as to whether maybe messaging nil is what's tripping you up. So keep this in mind. If we, the next time we get an email asking this question, we may refer you back to this slide. Another sort of question that is an outgrowth of that previous one is, so I was messaging this object, and it wasn't doing anything, and I checked, and it's nil, and I don't know why it's nil. Very common case here is IB outlet. So you've got some stuff in a nib, and you've got your files owner hooked up to it, and you've made the connections in Interface Builder. But then in your code, for some reason, that variable, the IB outlet variable, is nil. The reason why this most likely is happening is, first of all, remember that view controllers don't load the nib immediately. This is because you may be instantiating a bunch of view controllers when your application launches. Maybe if you have a tab bar-based application, you've got 3 or 5 or 10 different top-level view controllers for that tab bar controller. And you want to instantiate each of those and throw them into the tab bar controller. But we don't want to necessarily load 10 nib files from disk, because that'll take a really inordinate amount of time when you're launching your app. So don't try to access IB outlet variables in your init method, because most likely your view is not going to be loaded there. What you really want to do is use one of these two callbacks. One of them is view_did_load. Another one is view_will_appear. The difference here is that view_did_load is called a single time after the nib has been loaded and the view outlet from the view controller to the view has been hooked up. There are cases where view_did_load can be called multiple times if you unload the view and then reload the view. We haven't really talked about when this would happen. But for the most part, think of view_did_load as happening more or less a single time in the execution for your view controller nib lifecycle. Another place where you can write some code which deals with your views, especially if you need it to happen multiple times, is view_will_appear. So if you're pushing and popping, view_will_appear will be called on your view controller every time that you're pushed to it and it appears on the screen. Also, if you're viewing something else and then you pop back to it, view_will_appear will also get called. So keep in mind, view_will_appear can and probably will be called multiple times. But if you're doing something like maybe you've got a list of data that you've fetched from the internet, and every time your user navigates to that view, you want to reload and make sure that they've got the most recent data. View_will_appear is a pretty common place to do that sort of an action. Whereas view_did_load is a place where maybe just a one-time thing, like you wanted to set a background color on some view, and you didn't want to do it in Interface Builder for some reason. Those sort of one-time post-nib loading operations are things you would do in view_did_load. Does that make sense? Do you have any questions about this? All right. So today's topics, as I said, we're talking about data in your iPhone application. Specifically, there are sort of two big areas that we're going to be talking about. The first one is saving and loading local data. So data that you're storing on the user's iPhone, you're writing it out to disk, you're reading it back in, doing whatever you do with it. The other type of data that we're going to be talking about is data that exists somewhere outside your user's iPhone, off on the internet somewhere, on some server, and some of the really common ways to integrate with that type of data. So specifically, we're first going to talk about property lists. And then we're going to take a slight tangent and talk about the iPhone's file system, how it's laid out, what files you can access, which ones you can't. We're going to talk about archiving objects, and then SQLite, which is a really great way to store large data sets for your iPhone application. If you need to cache or store a huge amount of data, or actually even not so huge amount of data, but a case where you want to do random access and maybe not load the whole thing all at once, SQLite is a great option. Then we're going to talk about web services, specifically JSON or JSON, depending on your vernacular, and XML. We're just going to kind of touch on XML. And then finally, we're going to wrap it up with a little reminder about ways to share data within your application between different objects. So without further ado, let's talk about property lists. So property lists are a really convenient way to store a small amount of data. Property lists make it very easy to store common foundation types like strings, numbers, dates, as well as the container objects, which are really common, like arrays and dictionaries. You can even store raw, binary data in there. You can store just a stream of bytes and throw it into a property list, whatever that is. Maybe it's representing an image, representing something else. You can just kind of throw it into a property list. And there are a couple of different ways for a property list to be written out. There's a human readable XML format where you can, if you double click the property list and you view it, it's pretty easy to kind of pick through and see what's in it. Or there's a binary format, which is a little faster, but the debuggability is obviously less unless you're like Neo in the Matrix and you're just like reading raw streams of. So actually, the NSUserDefaults class is a really great example of something that uses property lists under the hood. As I mentioned, NSUserDefaults is a lot like a dictionary. Under the hood, it actually is basically using property lists, taking a dictionary with keys and values and all that sort of stuff, and writing that out to disk and reading it back in. So this is you're probably using property lists right now without even realizing it. Cases where you shouldn't use property lists. First of all, when you're storing more than a few hundred K of data, you probably don't want to use a property list. The reason here is that when you're loading a property list, it's really all or nothing. You can't bring in part of the file and leave the rest of it all on disk. When you load it, you're loading the whole thing. So if you've got an array with 10,000 strings in it and you've written it out to a property list and you want to get item 57 from that array back out, you're going to need to bring the whole thing back into memory. And obviously on the iPhone, that's problematic. Other situations where property lists maybe aren't the right move are cases where you've got complex object graphs. And by that I mean, you've got a lot of relationships between objects that you want to maintain. You've got this whole web of interconnected objects. It's difficult to get that written out to a property list in a sane way. And also custom object types. If you're using something other than strings, numbers, dates, arrays, and dictionaries, you may want to look into some other options. But property lists are very handy. They're super simple. And we're going to look at some really quick ways of getting into property lists. NSArray and NSDictionary actually have some convenience methods for both writing a property list out to disk. Either you can specify a file or a URL. And for reading from disk, you specify a path, again, or a URL, and it'll give you an NSArray or an NSDictionary. So that's pretty handy. These operate recursively, so if you've got an NSDictionary of NSDictionaries of NSDictionaries of NSDictionaries, it'll all kind of work. I mean, it all will work. I don't know why I just said kind of. I'm just undercutting my own message here. So let's see what this actually looks like. So we've got some array, and we've called NSArray, array with objects. Foo, we threw an NS number in there. How about an NS date as well? And then we nil terminate so that the constructor knows not to keep reading off the end of just a bunch of garbage memory into this array. You've seen this before. So at this point, I want to write this out to disk. So I would say array, write to file, and I would pass in the file name. I'm going to say yes for atomically. What this will do is write it out to a sort of temporary location on disk and then swap it in. So there's no chance that you'll end up with like a half-written file if the if the app crashes or the iPhone gets turned off or something like that. Always a good idea. And what you'll actually end up with on disk, if it's using the XML format, is this file. It's the XML that you probably know and love. Lots of brackets, very verbose. And you can see in here, we've got this array, and then within that array, we've got the 3 objects, strings, numbers, dates. It's all pretty human readable and great for debugging if you're just kind of trying to figure out what's going on in your application. So on the flip side, inevitably after writing an array to disk, actually, let's look at a dictionary first. So here again, we create this dictionary. It's got a name, it's got a lecture. I guess that's it. Write it out to disk, and you'll see here the keys and the values are sort of interspersed. So you can kind of walk through here and see what's contained in your property list. I guess I don't really talk about reading it, but one can only imagine. If you look back here, you call it in with contents of file. You pass that same path that we had before. It'll return NS array to you. So it's not really rocket science. Okay. There's some bits of code in this class called NS property list serialization that allow you finer grained control of how this property list gets written out to disk. First of all, those convenience methods that I showed you before will use the XML format. And if you want to use binary, or I'm not sure if there are other formats, I can't remember. I think there's some sort of legacy format. You can specify that. You can do more precise error handling. You can say whether or not dictionaries and arrays and all that kind of good stuff are mutable or not when you're both reading and writing. So if you're using property lists and those methods just aren't cutting it for you, fire up Xcode, hit Apple Shift D, type NS property list serialization, hit return. That'll take you to the header, and you can poke through there, or you can just Google for that term. Oh, hey, there it is. So if we've got a property list and we want to turn it into NS data, which we can then very easily, there are some other methods where you can take an NS data and write it out to a file. We can say data from property list, we can specify the format, and we can get an error back. Notice that this is an NS string double star, which is, so you pass in a pointer to an NS string star, and if there's an error, it'll populate that pointer. On the flip side, you can, if you've got that NS data, which you've read in from a file, you can call property list from data. You can specify some mutability options. As I mentioned, you can determine whether arrays and dictionaries are going to be mutable or not. And then the format and the error description, just as we did before. So a little bit more verbose. For a simple case where you're just writing some stuff out and you want to read it back in, you might not need these methods, but they're there if you need them. Any questions about that? So if you want to learn more about property lists, I would encourage you to check out this link, or just Google for property list programming guide for Cocoa, and it'll tell you everything I just told you here and more, and you can read and write property lists to your heart's content. This leads to, oh yeah. Yes, good question. So the question was, because NS user defaults use property lists under the hood, does that mean they all get loaded in all at once, all or nothing? And the answer is yes. So that's why NS user defaults are a great place to just store some values and some keys. But if you're storing 10,000 Twitter status messages or like a bunch of really big images in binary format, might not be the best place to put it. Great question. Yeah?
So using the methods you were showing on the previous slide, would you be able to define your own serialization for your own custom objects?
I believe the answer is no. I'm not going to say definitively no, but I'm going to show you a way you could deal with custom objects using a different sort of means. Any other questions? So all this talk about writing files to disk and reading files from the disk, this brings up some questions about the iPhone's file system and what files you can access, which files you can't access. The iPhone's file system is, you've got a lot of toys competing for space, and they all want to play. But we don't want them to, I don't know, my metaphor is kind of falling apart here. Your application is sandboxed, which means that if things go as intended, your application is not able to interfere with, or maybe on the more optimistic side, share data on disk with other applications. There are a few reasons for this. Security and privacy are obviously part of the picture, but probably the biggest reason is that when you delete an app from your iPhone, you don't want to have a bunch of files still sitting around on the disk. I, for one, am perfectly content to have a phone that does not have a file browser, that doesn't require me to every so often go through and say, oh, well, this app left this preference file behind, and this app left this 500 megabyte cache file. When you delete an app, all of the associated data should go away with it. So for better or for worse, there are obviously downsides to this approach. But this is how the iPhone's file system works, and how your sort of application sandbox is going to be happening. So what does this actually look like on disk? There's not really magic here. Basically, each app has its own set of directories for things like documents and caches. There will be a directory at the very top level, which has sort of very conveniently named universally unique identifier, a big gibberish string, and within that directory, you're going to have your app. And as we mentioned, applications themselves are actually directories. That app will contain, your app binary. It'll maybe contain some nibs and other resources along those lines. It might contain some images. Then going back up to the top level, to the application home, there's also going to be a folder called Documents for storing documents. A library where things like user defaults get stored for your application. Also caches, and yeah, preferences, user defaults, same thing. So each application is within its own folder. So when you delete an app, that entire application home directory is going to get deleted. Applications can only read and write within their home directory, and this entire thing is actually backed up by iTunes, with some exceptions during sync. Things like caches, and if you write to /temp, that sort of stuff won't get backed up and restored by iTunes. Yeah, question. Right. The question is, there's an app for setting custom wallpapers. How does that get files into the user's photo library? There are some interfaces exposed via UIKit or other places that do allow you to get it both read and write data to places outside your app sandbox. The key here is that you can't use the sort of low-level NS file manager or other sorts of APIs for digging through files on disk. Yeah, things like address book. You can obviously create new address book contacts. You can read address book contacts, all that sort of stuff. So there are ways to access it, but you probably shouldn't try and do it using NS file manager. Yeah. The question is there a way to access the user's music library on their iPhone or iPod Touch? My diplomatic answer to that will be there is not a way to do that on iPhone OS 2.x. If you go to Apple's website, there is a page with some announcements about 3.0, what's in it. And that is actually one of the things that's highlighted there. So I'm not breaking any big secrets by suggesting that there might be something in the future. So yeah, if that's something that you're interested in doing for your final project, that may be something where shoot us an email about it and we can talk about what the implications might be for you. Any other questions about your home directory layout, where all the files go, what happens to them? So you're still all of the sort of there's classes and methods in the foundation framework for doing things like creating files on disk, deleting files, all that sort of good stuff. And those things work as well on the iPhone OS as they do on Mac OS X desktop. The only distinction is that there will be places where maybe if you try to write to them, you're not going to be able to on the iPhone. So how do you actually access these paths in your app? There are a couple of basic directories like the home directory or the temp directory if you just need to store some files and you don't care if they get deleted or thrown away eventually. So there are some methods you can call to get a string which refers to the home directory or the temporary directory. If you want to get at the documents directory, there are a couple ways you could do it. You could take that home directory and then append /documents to it. A slightly more verbose but more robust way to do it is to use this NS search path for directories and domains and pass the NS document directory. That will return to you an array of paths. On the iPhone, there's just going to be one path here, but this is this method exists both on Mac OS X and on the iPhone. On Mac OS X, for things like the document directory or library or caches or things like that, there are sort of multiple levels of this. There's a per user documents directory, and there can be a per machine directory, all that sort of stuff. But this is sort of the most recommended way of getting at your documents directory within your application sandbox. And then if we wanted to get to, say, our application home /documents /foo.plist, the way we would create that path, there are a bunch of convenience methods on NSString. And you can do things like saying string by appending path component, and pass the path component. It'll take care of appending the slash in there if necessary. So yeah, it's one of those things where if you need to do it, it's probably worth picking through the iPhone OS documentation. But just quick and dirty, these are the ways to generate useful paths in your application if you need to read or write anything in your app bundle or in your application home. Now, one really common request is to include writable files with your app. So let's say you've got an application that stores recipes, and when your user downloads that app, you want to have 10 default recipes that are in that app, for apple pie and chocolate cake and whatever else, and you want the user to be able to delete those if they want, add new ones. But one catch is that your application bundle, the actual myapp.app part, which includes your app binary and basically anything the entire thing that your user gets from the App Store. That whole thing is code signed. What that means is you can't actually modify the contents of your application bundle. So seems like a problem. There's a really easy workaround though. If you've got some sort of starter database or a plist or whatever that you want to include with your app, include that file within your application bundle, within the myapp.app directory. And then the first time your application launches, you can check within their documents directory, which is not code signed, which is within your app sandbox, but it's not within the actual application bundle itself. I hope that distinction is clear. You can copy that file out to there and then do whatever you want to it. Does that make sense? This is not the most common thing, but just in case you need to do it, this is how you do it. Next, we're going to talk about archiving objects. So that question about custom objects, I've got some arbitrary NSObject subclass. I want to write that thing out to disk. I want to read it back in. This is how you're going to do it. And it's really the next logical step from property lists. You can include any arbitrary classes, some classes you defined that NS property list serialization doesn't really know anything about. You can also include complex object graphs, so it can maintain relationships between objects. And this, again, sort of in action, this is what Interface Builder uses when you're laying files out or laying interface objects out, and then you save that .zib or .nib file. It's actually archiving these objects and then reinstantiating them. So this is what's going on under the hood with Interface Builder. So if you want to make an object archivable, there's a protocol. Again, this is like a Java interface that you can conform to. And there are a couple of methods that you need to implement. The first one is encode with coder. And what this does is, given an object, well, here it's self, we want to write ourselves out. We want to persist ourselves. So as you can see here in encode with coder, we'll call through to the super method. And then let's say that we're a polygon and we want to be archivable to disk. So what we would do, we get this NSCoder object passed to us. Don't really worry too much about what exactly the NSCoder object does, but you're going to call on that coder object encode object name. Name here is probably a string. Strings already conform to NSCoding and they know how to encode themselves. And then you pass a key, in this case, name. Same thing for some integer. We've got an int instance variable. We want to encode that thing as well. So writing these lines of code will basically allow our object to be, freeze-dried and saved out, to disk or wherever. The counterpart is init with coder. And this is the method that actually gets called on a UI button or a UI view or a UI slider when it's coming in from a nib file. So this is why, the regular init with frame method doesn't get called. Because it's going through the NS coding protocol, the init with coder method. So again, here you would call through to self super init with coder, and this is the product placement part of the lecture. And here, these two methods will often look like mirror images of one another. You'll call coder decode object for key. You'll use that same string that you had before. And that'll actually return to you an auto-released object, whatever it is that you encoded beforehand for that key. Given that we want to retain this in an instance variable, I'm going to call retain here, because decode object for key doesn't have alloc or copy or retain in the title. Same thing for number of sides. This is just an integer. We don't need to retain it or anything. But we can call decode integer for key and pass a key along. So all this stuff with archiving objects, you're not going to need to do it for any of your assignments. But it's important to know that it's there. It's a sort of beefier alternative to property lists. It can do complex custom objects. But you're still limited in that it's kind of an all or nothing. You're loading the whole thing in from disk. Yeah. The question was, are these methods inherited from NSObject? I believe you need to conform to the NS coding protocol explicitly. Do you have to? That's a good question, actually.
Yeah, you do.
You do? Yeah. Al thinks that you do need to actually conform to this. These are not inherited from NSObject. Although that'd be funny if calling super. Obviously, the super class needs to have implemented it.
Yeah, I don't believe NSObject conforms to NS coding. So if you have an object that you do want, you have to implement it from scratch. There's nothing NSObject will write or read to disk, write to or read from disk.
That sounds right to me. But you might want to check the documentation. Obviously, this is not code that either most people write a lot. So always proceed with care. Any other questions? All right. So if we want to maintain relationships here, or like a whole array or dictionary of objects, we could do something like you call archive root object, and this root object is going to be something like an array, and we can specify the path that this thing is going to get archived to. And what this will do, it'll go through, it'll call encode with coder on all the objects in the array, and it'll write that whole thing out to disk. So this is how you would take a bunch of relationships and serialize them. On the flip side, let's try that one more time. All right, and we're there. So if you wanted to decode this thing using object archiving and unarchiving, you would call unarchive object with file, and there's this NSKeyed unarchiver class that you would invoke this upon. So it's there. It's there. If you need to use it, look into it. But you don't need it for anything presence related. If you want to know more about archiving objects, there's this Archives and Serializations Programming Guide for Cocoa. Google for that, or just click on this link in the lecture slides, and you should be good to go. Now, something that's probably more relevant to an application that you may be writing for your final project or something like that is SQLite. SQLite is a really, really great way to load and save data in your application. And what SQLite is, just a quick show of hands, who's heard of SQLite before? Almost the entire class, wow. Who's actually used it in code? A couple people, okay. So SQLite is a complete SQL database in a file on disk, an ordinary file. You don't need to have a database server running. You don't need to have a bunch of configuration, and you basically access it using a library with C methods you invoke that deals with this file on disk as if it were a full-on SQL database. It's very simple. It's compact. It's fast. It's reliable. It's especially great for embedded systems like the iPhone. Situations where you don't have a ton of RAM, a ton of CPU to throw around. As I mentioned, there's no server. It's just a file and the APIs that you're using to interact with that file. And it's included on the iPhone platform, conveniently enough. So here's a little quote from the author of SQLite. And just as you have received SQLite for free, so also freely give, paying the debt forward. This isn't like a GPL sort of thing here. You're not like signing up to give your app away for free. But it's pretty cool that this library is actually available for free. It's open source. All the documentation is out there, out of the kindness of Richard Hipp's heart. He'll also, if you need support or you need to ask questions, I think that's where he pays the bills. But that's sort of the overriding philosophy of SQLite. But there are cases to use it. There are cases not to use it. If you've got really, really huge databases, you may be better off, well, you may be better off not writing an iPhone application, multi-gigabyte. I don't know how that's gonna work out. If you've got high concurrency, like if you've got a database that needs to be hit, from a lot of threads, multiple threads works out okay, but especially if you need to have, if you want to put a SQLite database on some remote file server and then have a bunch of apps all writing to it and reading from it, that's not really what SQLite is designed for. You're probably better off going with a real, full-on, big, heavy, SQL server. And like I just alluded to, client-server applications, if you've got your client in one place and your server in one place, using SQLite may not be the best approach. Although there are certainly, there's plenty of Ruby on Rails apps out there where the backing database, at least, in the sort of initial stages, is a SQLite database. There's some more, comments on this, when to use SQLite, when not to use it, at this link. I would encourage you to check it out if you find yourself asking the question, well, does SQLite really make sense here? So let's take a little quick look at the SQLite C API basics, and then we're going to actually look at some sample code as well. So just the bare bones, how do I open a database, read some content from it, just the hello world type stuff. If you want to open a database, you've got a path to some file on disk, which you're certain, or you're pretty certain is a SQLite database. There's this function you'll call. These are all C APIs. SQLite 3 open. You'll pass the file name, and you'll pass a double star database pointer, which will get populated with the database object. And this database object is what you're going to be performing operations on later in your application. Excuse me. And then you want to execute a SQL statement. Most of you, well, you raised your hands about SQL. How many of you are familiar with SQL in some fashion? You took CS, what is it, CS 145? 140, not 143, 145, yeah. Okay, so a lot of people are, doing things like insert statements, select statements, all that kind of stuff. So you'll pass the database as the first argument. You'll pass a C string, which is the SQL statement, is the second one. You can specify a callback method, which will be invoked for every row in the return set. And then you can also pass some context, which will be included in that callback, and you can get an error back. So this is like the sort of one-shot, take a SQL statement, run it, give me a callback for each row, and do it all up. There are alternative ways of executing SQL statements where you actually take the statement and you compile it, and then it's a sort of multi-step process, which you may want to look into. Read the documentation, and they can explain it better than I can. So then your callback here, that third parameter, is some function which you've defined and you've specified here, and it takes a generic pointer, which is the context. Maybe you wanted to identify which particular query this callback is coming from, so you specified that in the pointer. It'll give you a count of the number of columns, and for each column, it'll give you the value, or it'll give you a char double star of the values and the column names. And this will be invoked for each row in the result set. And finally, all good things must come to an end. You're going to want to close the database at some point, so you call SQLite 3 close and pass the database pointer. So just like retain, release, malloc free, anything else, you close the database after you've opened it. So let's look at a quick little demo here. The first thing I'm going to do from the macOS 10 command line actually is to show you how the SQLite command line utility works. So I can type SQLite 3, and I can actually type the database name here. Let's call it names.db. So now I'm in the SQLite shell. Let's see, is the font here big enough? Can you guys see it all right? Let's crank it up just a smidgen. Oh yeah. Okay, so here I am in SQLite. I'm in a new database file. This database doesn't have any tables. It doesn't really have anything defined about it. Let's look at my cheat sheet here, right? So the first thing I'm going to do is create a database table. So let's type, good old standard SQL. Create table Here, I'll just leave it right there. So create table person, and this person table is going to have 2 columns in it. The first one is the unique ID. Whoa, what just happened there? My console freaked out. All right, create table person, unique ID, integer, primary key. And then it's going to have a name column, and the name is just text. I'm going to semicolon, terminate that, hit return. It's all good. If I want here, I can actually type .dump, and it'll show me the SQL statements that were used to construct this database thus far. Next, I'm going to insert some values into here. So I'm going to insert into person, just the name column. I'm going to let the primary key auto-increment itself. And the value is going to be Evan. So now if I want, I can type dump here. It'll show me that I created the table, and I inserted into it. And if I want to see what's in it from the viewpoint of the SQLite C API or any other SQL API, I can say select star from person, and it'll show me, that the primary key is 1. This is a unique identifier for each row, and the name is Evan. So then I can, copy and paste some other ones in here, just like that. And now if I type select star from person again, we've got me, Al, and Shaq from the Presence 2 demo. So this is now, a real live database on disk. If I type exit here, I've got this names.db on disk. I can open it up. I can do that select statement again. All the stuff is still there. It's all been persisted out. So now what I want to show you is the C SQLite interface. So I've got this project here, and we've got the names DB. Just for kicks, I'm gonna copy in the one that I just created, so you know I'm not pulling the wool over your eyes. And here we are in Xcode. And this is based off of our table view example from last class with Jason. So we've got a table view controller. We've just added it to the window, and we're letting the table view controller do its thing. This code you should be pretty familiar with at this point, creating a view controller and adding its view to the window. Let me wrap this text here. There we go. Hopefully a little bit more readable. Now let's check out this table view controller subclass. The first thing to notice is that we're importing SQLite 3.h. We can call import isn't just for Objective-C, it works for C files as well. If I double click on this and I hit, what is it? Apple Shift D? No. And then I hit return. It'll actually open up the SQLite 3.h file inside my iPhone simulator SDK. So here's, in place of the legal notice, here's the blessing. You go through here, and then there's there's a ton of stuff in here. All of the SQLite methods or functions are defined in this single header. So if I want in Xcode, I can click here. Here's all the sort of pound defines. Here's all the functions. Basically, it's a whole lot of stuff. Conveniently, everything in this header file is available online in a much more readable format. If you search for, I think I've got the link later in the presentation, but you can view all of these comments and documentation in a, web browser, Etcher, however you like. So we import SQLite 3.h so that we can use SQLite, and then if we turn on wrapping again. So here's our initWithStyle method. This is the standard UI table view controller initializer. I call super. I create this names array, and then I've got this helper method that I've defined, which is load names from database. So let's scroll up here a little bit, see what this method actually does. Not a lot of lines of code. I'm going to create I'm going to create a path to the file, and here this database actually is going to be built into our application bundle, like I was talking about before. So I get the main bundle, and I ask it for the path for the resource called names of type .db. That's just the extension I happen to use. I then declare a SQLite 3 database pointer. It's nil to start with. And then I'm going to call SQLite 3 open. And like I said before, I pass it a string. It's a C string, so I'm going to pass file UTF-8 string, which returns a char star. Convenience to return a null terminated UTF-8 string. Because this is all C, it's not Objective-C. I check the return value. If it's SQLite OK, then I'm going to execute this SQL statement on my database. And I'm going to say select name from person. And it's going to call my callback, which is a C function that I've defined. Is there a question over there? No? OK. I pass some context. Because this is a C function, we're not going to have access to all of our instance variables. So the particular IVAR that I'm going to want to use in this callback is that mutable array of names. So I'm going to pass that as the void star context. And then once this is all done, I'm going to just close the database. So if we look up here, this is the actual implementation of my callback. Again, it takes the context, which in this case is the mutable names array. If I were to say something like, self do something here, that'll be problematic because self is not defined here. We're outside the implementation of my table view controller. This is no longer an instance method. This is just a regular old C function, like you know them and love them, sitting out there in space without any idea about objects or anything like that. So we don't want to do that. We pass in our names as the context. And then for each row in the result set, actually, yeah. So for I equals 0, I is less than count. Count is the number the number of columns. I'm going to, I misspoke earlier about what's actually returned here, columns versus results. So in this method, count is the number of rows returned. And then I'm going to create a C string out of the values array here, and I'm going to turn that into an NS string and add that to my names array. So hopefully that makes sense. This will be up on the website for you to poke around at if you're curious. And then return SQLite OK, so that the SQLite knows that it's all good. Probably worst explanation ever.
Where is names coming from? Because that's outside.
Right. So right here, I actually redeclare names as a local variable. I've got this context here, which is passed in as the first argument in this C function. Back down here, when I called SQLite 3 exec, for the 1, 2, 3, fourth argument, I actually passed names when I was in the Objective-C method as the context. So that will come in as just a pointer here, which I can then cast into an NS mutable array. Yeah.
Right. So I'm a little confused here. So this gets called on each row, or on all of the rows with count as the number of rows?
So I think for maybe the distinction here, and I actually haven't written SQLite code since the last time I gave this lecture, but I believe what's happening here, at least deducing from the code up here, is that this is called once for the entire result set, which for some reason, yeah, I think that's what's going on.
So do you know what the columns argument is?
Well, I've specified the columns down here in my SQL statement. So when I said select name, I know that there's just going to be one column returned, and it's going to be the name column.
So it's like the names of the columns then?
Yeah, exactly. Yeah, it's kind of funny to have one of our columns which is called name. It kind of makes things a little bit more complicated. Yeah, these are the values, and these are the actual names of the columns. So yeah. Then to actually get this to display on the screen, as we've seen now with UI table view and UI table view controller, there's this method which we've got to implement. Well, two of them actually. One of them is number of rows in section. We're just going to return the count of the names array. And then for the self-erode index path method, we're going to create a UI table view cell. We're not going to use a reuse identifier, which will make Jason really mad when he sees this, but it's only got 3 rows. And then we're going to just say cell.text equals names object at index path.row. So this will get the name, and set it as the cell's text. So now if I save and I build, should build without any issues here, and I hit run, you'll see that here's all this content in the table view. So now if I go back in here and I add some more content, let's go to the SQLite table view, names.db. Troy. And exit. Now if I run this app one more time, you should see Troy was added to the list. So quick and dirty, this is how you get at the SQLite APIs. And obviously if you want to do more complex things in your app, especially writing stuff out to the database, you're going to be kind of on your own, but the documentation is pretty good. But this should get you at least on the right path. More on SQLite. SQLite in 5 minutes or less. There's this quick start, which you can check out, and also the intro to the SQLite C interface. Those are both good to read. Yeah, question?
Do you know if there's a web administration tool, like for MySQL, you can use a PHP MyAdmin or something like that? Is there one for SQLite?
So the question is there a web admin or other type of admin tool for dealing with the SQLite database so that you don't have to be in there searching around on the command line? Is that what you're asking? Yeah. There are desktop Cocoa applications which you can use to open up a SQLite database and visually muck around with what's in there. I don't know the names of any of them off the top of my head, but if you go to Google or Mac Update or something, you can find them there. Any other questions about SQLite? One other thing which is worth mentioning here is that there's this thing, if you've done Mac programming in the past, called Core Data. Core Data, this is straight from the marketing page on the Apple website. It's an object graph management and persistence framework. And what that really means is that it makes it really easy to save and then load sets of objects, as well as their, both their properties and their relationships with one another. And you end up writing a lot less code than you would if you were using keyed archiving and unarchiving. And it's much higher level than something like SQLite, where you're down there, at the C level, you're invoking the SQL statements. This is a much higher level abstraction, where you've just got these objects and you occasionally tell the context that these objects all live in to save. It's a really, really great framework. Makes it dead simple to create an application which deals with large quantities of data. It's available on the Mac OS X desktop. It's not available on iPhone OS 2.x. If you go back and watch the iPhone OS 3.0 preview announcement, you'll see there's a couple slides there where it's like, here's all the new APIs in iPhone OS 3.0. And if you look at it with a magnifying glass, it does mention Core Data in there. I'm not going to discuss it any further than that. But if you're interested in using Core Data in an iPhone application, that may be something you want to check out. So now let's look at the second half of the lecture. We're going to talk about web services, specifically your application and a bunch of data that doesn't live on your user's iPhone. Maybe under your control, maybe under someone else's control. And actually many Web 2.0 apps and sites provide developer APIs, and that's what we're going to be using for the present assignment with Twitter. They expose a bunch of APIs in both of the two formats that I'm going to be mentioning, XML and JavaScript object notation. So this is a great way to not write a lot of code, not fire up a big server on a server farm someplace, but actually still be able to make your application interact with remote data out there. It allows people to say things like this. I made a location-based user-generated video blogging mashup for pets using Web 2.0, web services APIs. But to be clear, an explicit non-goal of this class is to teach you everything there is to know about web services. There's tons of tutorials out there. You can search on Google for all the ins and outs of web services, especially implementing them on the backside. Many are exposed via RESTful interfaces with XML and JSON. What that means is that there isn't a lot of state on either side. It's not like SOAP where you're actually invoking functions. You're basically just making URL requests. You're requesting some resource with the URL, and you're getting some data back. And it's a lot of these sort of one-shot transactions. What we are going to do is give you a high-level overview of dealing with these types of data on the iPhone platform, and we're going to do a quick little demo of JSON parsing. So really quickly, XML. XML is obviously a broad topic, and XML itself is a pretty generic thing. It's this format for specifying keys and values and data. There are a few options for parsing XML on the iPhone. The first is a low-level C API called libxml. It actually has 3 different options for parsing. There's a tree-based, a DOM parser, where you basically take this XML file and you read it all in, and you've got the whole tree instantiated, and you can walk through the tree and say, ask for parent and child nodes and all that sort of stuff. Easy to parse. You've got the whole thing there. You can walk around the tree however you need to. The problem here is that you've got the entire tree in memory. So as we've mentioned in a few other cases, this tends to be not a great thing to do on the iPhone, especially with web services where you don't necessarily know how much data you're going to get back. And maybe you get a ton of XML data back, and keeping all that data all alive in an XML object tree is not going to be a good thing. So another option is this event-driven, SAX-based API. It uses less memory. The problem here is that you've got to remember the relevant bits of state about the XML that you've already parsed, because you can't go through and backtrack. So less memory, but you're going to have to sort of roll your own state management. A third option, which is this kind of quick and dirty, sort of like SAX, but you have to maintain a lot less state, is this thing called the text reader. It's fast, it's pretty easy to deal with, it makes for great sample code, and it's pretty efficient as well. On a slightly higher level, there is this Objective-C class called NSXML parser. It's an event-driven API, so it's similar, similar to the SAX-based APIs in libxml2. There's the typical trade-off here. It's a little higher level. There's a little less you can do with it, but it might be worth looking into. In addition to all this, there are actually plenty of other Objective-C XML wrappers, sort of higher-level abstractions for dealing with XML. I've never used any of them. Supposedly some of them are pretty good, and I'm sure that an enterprising Google user could find out more about them. So a couple of links here. There's a quick little tutorial on using libxml and the XML text reader, which illustrates use of this much better than I could. Here's the link. It'll be in the PDF. And it actually includes an example of parsing Twitter XML. So very relevant here. There's also this Big Nerd Ranch blog post. Big Nerd Ranch does all these like Cocoa and sort of other sort of software engineering classes that are supposed to be pretty cool. And they have a blog post about NSXML Reader, which is a great place to start. I found both of these with just a casual little Google search session. I'm sure you could find a lot more if you're interested in parsing XML. But we're not going to be doing that in this course. What we're actually going to be using under the hood for the present assignments is JSON, which stands for JavaScript Object Notation. And JSON is more lightweight than XML. And it actually, especially given that we just talked about property lists, it's very, very, very similar to property lists. It's a nested series of arrays, dictionaries, strings, numbers, Boolean values. So if you know property lists, this will look very, very familiar. And actually, for this course, we're going to be using an open source wrapper for Objective-C that allows you to very trivially go from a bunch of arrays, dictionaries, strings, all that stuff, to a JSON string and vice versa. It's called JSON Framework. You can Google for it. It's up on Google Code. I believe it's definitely open source because we're including the source for it as part of the presence2files.zip up on the website. So this is what we're going to be using in this class to deal with web services APIs. What does a JSON string look like? I thought this might be helpful just to kind of illustrate what's going on. It'll begin with a curly brace. This indicates a dictionary. In JSON, it's referred to as an object, but it's basically a series of keys and values. So for each entry in the dictionary, in the object, we're going to have a key, which is a string, and then we're going to have a value, which in this case, here we've got a string. It could be a number as well. It could also be certain keywords like true, false, null, yay. So these are all defined at a website that I'm gonna mention to you. But as you can see here, it's a lot less verbose than XML. Imagine what this would look like in XML, and you've got brackets, and you've got opening, closing, and it's a little bit more sparse, a little bit more simple. You can do things like having arrays in here. So for the key assignments, we've got the value, which is an array defined by the square braces. I could even, I could substitute in a dictionary in here. I would use the curly braces. So the value for some key might be another dictionary, which has its own set of keys and values. So seeing the parallels here, property lists, JSON, they work pretty nicely together. This will be in the lecture slides. So actually using JSON framework. So this is the specific open source Objective-C wrapper framework for dealing with JSON strings. So the first thing we want to do is take some JSON string that we've gotten over the web. Maybe we made a URL request and we got back this data, and we want to parse it into useful foundation objects like arrays and strings so that we can use it. We're first going to import JSON/JSON.h. Actually, in your assignment, you'll just be importing double quote JSON.h because you're going to be copying the files directly into your Xcode project. From here, let's get a JSON string from the cloud. I'll be showing you an example of this, how you would actually make the URL request and get a string. But let's say we've got some string and it contains JSON content. I'm basically just going to call this method JSON value. This is a method on NSString added via a category, which we've sort of alluded to in a lot of places in this class. We haven't really talked about them in depth, but the basic idea is that in Objective-C, you can actually add methods to an existing class. So something like NSString, there's this, something like getting the JSON objects out of that string is something that may be useful for a lot of consumers of NSString, especially, in this application. So you can actually define something called a category, which adds these methods dynamically to the NSString class. So I don't need to, invoke some other class and use some other methods. I can just say JSON value on an NSString instance, which is kind of cool. So from here, this object, the JSON parser doesn't, well, we don't necessarily know via this API whether that thing is an array or a dictionary. You'll probably need to, poke at this thing either in the debugger or maybe read the documentation of whatever web services API you're using to find out what's in it, how you use the data. So, anytime you've got a dictionary, you need to know what the keys are. And there is no inherent information about the keys. It's all kind of loosely defined. If I want to write a JSON string from foundation objects, let's say we create some data in our application, in a dictionary, for example, and we want to turn that into a string. There are equivalent category methods defined on NSDictionary and NSArray, which allow you to get the JSON string representation from that dictionary. So just one method here, and you go from a dictionary, which may contain, God knows what, into the string, which you can then, if you need to send a JSON request, this is probably less common. The reading case is going to be what we're mostly doing in this class. But you can turn that into a string. Any questions here? Let's do a little demo here. So I'm going to be using Flickr's public developer API, and I'm going to be fetching some images and displaying them. And this will be up on the website. So here we've got another sort of table view based application. My table view app delegate, this code is all the same as it was before. Here's where the interesting bits lie. If you're interested, you can check out Flickr.com. Flickr is a photo sharing website. Here's all the information about their APIs. Again, in my initWithStyle method, I'm going to have an array of photo URLs and an array of photo names. And then I'm going to call this load Flickr photos method. And what that's going to do is, here's load Flickr photos. Now, one thing to note before I get into this, all of this is going to be happening on the main thread. So what this means is that if the network is down or the network is slow, and we launch our app and we're trying to get this information from Flickr, our app is just going to sit there with a black screen, which is not great. iPhone's network connections can be unreliable. Your user might be on an airplane or in a subway tunnel. So actually on Monday, right? Monday, we're going to be talking all about avoiding that, avoiding blocking the main thread. But for this demo, and actually for your Presence 2 assignment, we're going to let that all slide. We just want to get the basics of using table views and getting remote data. So don't worry too much about whether you're blocking the main thread or not. So the first thing we're going to do is construct a Flickr API request. So this is just an NS string, and I'm going to turn that into a URL. Here's the format of the string. It's this big old URL. It includes a Flickr API key, which I've defined elsewhere in the app. I didn't want a million people on the internet using my Flickr. This is assigned per user, so I didn't want you guys to be all slamming Flickr and saying that it was me. If you want to use this yourself, there'll be a file included with this sample on the website where it says enter your Flickr API key here, and you can get one for free at the URL that I mentioned above. And I want to search for a phrase. I want to search for Stanford tree. So we're going to find some images. They're tagged with the tag Stanford tree. You can pick through this URL if you're curious, and also look at the API documentation up at that URL. So I construct this string. I create an NS URL out of it. In this case, I just call it URL with string. And then I'm going to call NS string with contents of URL. I pass the expected encoding, which is UTF-8. And this will actually go out to that URL, get the contents of it, and return the result in an NS string to me. So this is the method that's going to block. It's synchronous. It's going to, the main thread is just going to be stuck there until this thing returns. So this is great for illustration purposes. Ultimately, there's some more secret sauce that you're going to want to throw in here from the next lecture to make your app really, really fly. The question is, are there timeout parameters? Yes, there are ways to make a URL request with a timeout. I don't believe you can do that. This is just a convenience method on NS string. I believe the classes you're going to want to look at for that are NSURL request and NSURL connection, and then you can specify all sorts of good stuff there. So we got this string back, and like I said in the lecture slides, I'm just going to call JSON value here on that string, and that's going to return to me. In this case, I know it's a dictionary, so I'm just going to assign that to an NSDictionary star. And then from here, I've got this dictionary. I'm going to call, what do you do with dictionaries? You call object for key. So I'm going to call object for key photos. I'm going to get these photos out. I'm going to ask it for the title. I'm going to construct a URL for each photo because it returns to me the means of constructing a photo URL. And I construct that, and I'm going to add the photo URL to this array of photo URLs. Down here in the self-erode index path, well, number of rows in section is just the number of photo names. So up here, we basically ended up constructing an array of photo names and matching photo URLs. Here's our number of rows, and here's our self-erode index path method. And what we're going to be doing here is, we've got a cell. We're going to set the cell's text, just like we were doing before in the SQLite example. And then here, this is going to be another blocking call, which would be typically, especially in a shipping iPhone app, very bad to do on the main thread. But I'm going to call NSData, data with contents of URL, and I'm going to pass the URL for my array. This will go out over the network. It'll fetch all that stuff, and it'll return the raw byte stream as this NSData object. And from there, what I can do is actually create a UI image from that data that I got remotely. Does this make sense here? Kind of what I'm doing on a high level. So if I hit save here and build and run this application, if all goes according to plans, see, we're gonna have a little black screen for a little bit because we weren't threading it. But here are real live photos coming in from Flickr. We've got the title. We've got the image. I don't know what's going on there. Looks like the tree got kidnapped. Yeah, so pretty cool. Not a lot of code, and you can go out there and basically, the internet is your oyster. So for more on JSON, there's the JSON framework documentation and the code. It's up on Google Code. You can also visit json.org for high-level overview. Well, high-level, and it also dives in pretty deeply. You can find out everything there is to know about the JSON file format. Last thing I wanted to cover in lecture today is just a reminder about application data flow, how you might want to pass data around in your application, especially now that we're fetching data and we're going to be maybe diving down into detailed views. And we're going to have something like a person object, and that person has an image and a name, maybe some status messages associated with them, and how you get that data from, say, the list view to the detail view. Your object may need to share data, especially in in the presence application, you've got this list and you've got this detail view. And you really want to avoid using globals or things that you can treat as globals as a repository for all of the data in your application. The problem here is that if you've got this detail controller and you want to pull it out and use it in a different application, this detail controller is going to be assuming that this app delegate exists out in space with all this data ready for it to use. It's not, it's not really self-sufficient, self-standing. So what you really want to do to make your code maximally reusable, testable, debuggable, all those good, all those good things, you're going to want to figure out exactly what needs to be communicated, define the input parameters. So like maybe have a property on the detail controller, which is person, and that's the person that detail controller is going to display. And then when it's time to display that detail controller, pass that data along. Say, here's your data to display. That means if you pull this out and use it in another app, that other app using that detail controller, same thing. It just sets the data, and then it's ready to go. There aren't these external dependencies from within the detail controller. If you need to communicate back up the hierarchy, you can provide some way of the list controller to say, hey, I care about certain events when they occur. Maybe when you hit the delete button on the detail controller. So that when that happens, the detail controller can say back to the delegate, back to the parent object, without knowing too much about the specifics of it, whether this is a presence list controller or a Facebook API list controller, whatever. It can communicate back in a generic fashion. One other topic I'd like to cover is that if you do decide to define your own delegate, I don't think you need to do it for presence 2, but maybe for presence 3. Delegates are typically assigned, not retained. This is because you've got this parent object, like the list controller, and the child object, the detail controller. And typically, the parent will already be retaining the child. So it would be a problem if the child was also retaining the delegate, which might be its parent. So the pattern is almost always delegates are assigned rather than retained. This means that, let's say we're within the person detail controller, and we're deallocating ourselves. We need to make sure if we, let me reverse this. Is this right? If other object.delegate equals self. This code sample here might be a little bit screwy. I'll correct it in the slides. But basically, the thing to remember here is that when you're deallocating, if you are another object's delegate, you're going to want to nil out that delegate reference. So basically, what's going on here is that if the list controller is going away, but maybe the detail controller isn't, who knows why that might happen, but if it did, the list controller should say to the detail controller, hey, I don't want to be your delegate anymore. Don't tell me when the user presses that big red delete button, because I'm going away, and if you send a message to me, you're going to crash. So that's what that's trying to say. So quick recap, property lists are quick and easy, great way to throw some data on disk and get it back, but they're limited. They only work for primitive data types. Archived objects are more flexible, but they're pretty complicated. You've got to write these init with coder and encode with coder methods. You've got to write a lot of code. SQLite can be an elegant solution for a lot of types of problems. You're dropping down to that C API, and you're sort of dealing with raw SQL. If you can use a higher level abstraction, I would almost always encourage you to try it at least. XML and JSON are kind of low overhead options for talking to the cloud and making your app, extending your app in some interesting ways. And finally, design your data flow thoughtfully. Don't just kind of have data flying all over the place. Think about where the data needs to go, who needs it, and how it should get there. And that's it.
For more, please visit us at stanford.edu.